Hi, my name's Jeff Cady. I'm a health physicist and a radiation protection professional, and I am going to develop a series of videos to help the new person that wants to break into the industry or learn how to be a technician, or somebody that maybe didn't get a good grasp on the fundamentals in their initial training and just needs a little refresher. Today, I'm going to cover a very brief overview of the periodic table of elements, protons, neutrons, electrons, and then we're going to jump into a very brief introduction of the chart of nuclides and how we use the nomenclature, so how we write the symbols and different isotopes and those sorts of things, and ZXA notation. And all of this is important for later discussions where we start talking about alpha decay and beta decay and what happens with the gamma decay and those sorts of things. So these are kind of building blocks and getting the fundamentals behind you. At the end of this, there's going to be a link to a quiz where you can go do practice quizzes to help solidify the concepts. If you just watch the video, you're not going to remember much, but if you go actually practice and take some of the practice quizzes, you'll help solidify the concepts and it'll prepare you for future videos and your learning process. This is the common periodic table of elements that you've seen in primary school. This is a slightly stripped down version, but if I zoom in a little bit, you get a little more of the detail you may remember or may give you nightmares from your high school science classes and those sorts of things. First element in the upper left-hand block is hydrogen, and there's a little 1 depicted on the upper left-hand corner. That corresponds to the number of protons in the nucleus. The number of protons tells us what the element is. Every atom of hydrogen in the entire universe has only 1 proton inside the nucleus. You look down and the next one beneath that is lithium. Lithium has 3 protons in the nucleus. It will always have 3 protons in the nucleus, and it's that way throughout the entire universe. Now I'm going to jump over to the other side of the periodic table of elements, and you'll see helium. Okay, so helium has 2, and there's other common examples here. So for example, maybe we'll hone in on, how about we hone in on cobalt? Cobalt is a nuclide we're going to end up talking a lot more about in the series of videos I'm going to do. But you can see here that cobalt has 27 protons in it. And this periodic table of elements tells us a lot. It tells us a lot about how things will react chemically in the chemical world, but it doesn't tell us anything about the nuclear world. We need a different set of tools for that. The tool we use to explain that is the chart of nuclides. And we're going to use this quite a bit more extensively, but you can see this one is arranged a lot differently. If I zoom way out, you can get a feel for how the overall chart would look. If I put this in little 1.5 centimeter blocks and I cut and pasted it, it would fill up a standard size wall, no problem. But I'm going to zoom in here to help explain a little more about how this is structured. And we'll come down to where we were looking at some of those other things. Now, notice on the horizontal, the horizontal portion of this chart, that is increasing number of neutrons. And on the vertical axis, the z-axis, it's increasing number of protons. So just a little bit ago, I'd mentioned that every element or every atom of hydrogen in the universe has 1 proton. You can see that row, that first row, all is hydrogen because all of those have 1 proton. The very first block in this shows similar information that you would see on the periodic table of elements, and then we start here with 0 neutrons and 1 proton, and that makes up hydrogen 1. 99.9885% of all the hydrogen on Earth is made up this way. It's hydrogen with no associated neutron. Hydrogen 2 is the next one in line here. That has 1 proton because it's in the first row, and it has 1 neutron because it's in the 1 neutron column. So H2 would depict that it is hydrogen. The next one over is a common one that we talk about frequently, and that's tritium. That has 1 proton and 2 neutrons. I'll do a whole nother video on the chart of nuclides and more about how we look at half-lives and neutron cross sections for absorption and what the color schemes mean and all that sort of stuff. But for now, what I want you to note is that we have this chart of nuclides, and it's arranged with increasing number of protons on one axis and increasing number of neutrons on the other axis. And just for fun, I'm sure you've all heard about uranium-238 before, or uranium-235. And if we look at where that's on this periodic table, on this chart of nuclides, it's way towards the top. So there's lots of protons and lots of neutrons in a natural heavy element like that. Okay. All right, so not going to spend a lot of time on chemistry concepts, whatnot, but you see the standard depiction, the Bohr model, if you will, of an atom. This is not technically accurate, but it's good. It's a good model from an educational perspective, and it helps emphasize a couple of points. One, the neutrons and the protons are in the nucleus of the atom. This is what we call the nucleus of the atom. Okay, this whole portion. For the purposes of this discussion, that's all the more we really want to talk about. You can go back and review your chemistry notes for those portions, because we want to dig more into the nuclear process and how radioactive decay occurs and why that poses a problem for humans and what we do about it. You saw on the chart of nuclides some notation where, for example, they would say cobalt 60. Okay. That is useful to us. We already know it's cobalt. And 60, that particular number tells us what the mass number is. Okay, this number would be known as the mass number. We don't know how many neutrons or protons are in there just by this particular annotation, so there is a more useful annotation for the purposes of things we will do in the future, and that's called the ZXA notation. The Z number is known as your atomic number. That is the number of protons in the nucleus. The X is your elemental symbol, and A is what we call the atomic mass number. And that is the sum of the protons and neutrons. So ZXA, we have the atomic number is the Z, the elemental symbol, and then the atomic mass number. So if we took that cobalt 60, the way we would write that in a little more useful form, we'd say it has 27 protons, and the elemental symbol is cobalt, and there's the atomic mass number is 60. Now again, that 60 is the sum of the protons, which includes this 27, plus all the neutrons. So we get a little more information out of this. We can figure out how many neutrons are associated with cobalt 60 simply by subtracting 27 from the 60, which tells us that there are 33 neutrons associated with cobalt 60. A common test question would be to list an element in ZXA notation and say, what is the number of protons associated with this element? What is the number of neutrons? What is the atomic mass number? What is the atomic number? So these are very common test questions that you'll see if you're studying for exams, and it's helping you to understand a couple of other key concepts that we're going to dive into a little more in the future. Let's give you a little taste of a practical example of how we'll use that ZXA notation in future videos. Let's stick with cobalt 60 in this particular example, which we knew had 27 neutrons. So I'm starting off with an atom of cobalt 60, which happens to be radioactive, and I happen to know it undergoes what's called beta minus decay, where a neutron turns into a proton. And we would write that this way. We would say the decay occurs, and then since a neutron turned into a proton, my atomic number increases by 1. I now have 28 protons in the nucleus, which changes the elemental symbol. Okay, the element that corresponds with having 28 protons in its nucleus is nickel. And now for the atomic mass number. The atomic mass number is the sum of neutrons and protons. And since I increased my proton by 1, but I decreased my neutron by 1, the mass number stays the same. So cobalt-60 decays into nickel-60, and it gives off a beta minus particle and what we call an antineutrino, which you'll learn more about in the future. But understanding the ZXA notation will help us describe radioactive decay and tell us what one substance will decay into for the other. And we'll use that when we come back to the chart of nuclides. And in this case, we'll find cobalt-60, which you should see center screen here. And it'll show that it decays up and becomes nickel-60. And that helps us explain why the mass numbers are the same and why it goes to a different row. So more to follow on that. That was a very quick overview of some pretty important concepts. So now what I'd really like you to do is follow the link that's in the description, or I'll try and put a little a link somewhere on here on the video here. And I'd like you to go and practice a quiz or two. If you don't do well the first time, that's okay. That's how you solidify the information, is by practicing, and using some dynamic online quizzes, we can accomplish that. I hope you got a little something out of the video. I'm looking forward to creating some additional content and hearing other things that you would like explained a little further, or things that maybe in your training you were like, I didn't quite get that, can you help explain that? I like doing that sort of thing. So if you have something, leave me a comment or a request. And you can always hit like and subscribe if you want to be notified of additional videos that are going to be coming out here in the near future. Thanks.